Hi, this is Xudong Lin. I am a PhD student from Columbia University. I will introduce our work on learning to recognize procedural activities with distant supervision. This work was done when I interned at Meta AI. Imagine you watched some cooking videos from the chef Gordon Ramsay, and you decide to cook one of his most famous dishes, beef Wellington. You easily finish the first step, which is to simply sear the filet mignon to brown. The second step is not hard either, which is to fry the mushroom until they are dried. However, you forget the next step. Luckily, in this imagination, you are the everyman. Your AI assistant Jarvis comes to help you. It can actively understand the task you are trying to accomplish, the steps you have done, and make suggestions for the next step. In this work, we aim at building the foundation for such AI assistants. But how to make it? The first thing is definitely to recognize steps from various tasks. However, even in the largest manually labeled dataset, only almost 200 tasks and 800 steps are covered in total. Therefore, it is clear that the manual annotation is not scalable. You may also know recent work on using sentences from automatic speech recognition as the supervision for video representation. However, supervision from ASR is weak and noisy because of the imperfection of speech recognition system and the weak alignment between speech and visual content. The second thing the AI assistant needs to know is the procedural knowledge of task step structures. People can summarize such procedural knowledge into a knowledge base like wikiHow. It contains numerous articles about different tasks, and each article is a step sequence to accomplish certain task. Wait, what did you just say? wikiHow? Yes, that's exactly what we need. We propose to construct a distant supervision based on knowledge from wikiHow to supervise a video encoder to produce step-level representations. Specifically, we first construct the step knowledge base by collecting the steps from the 1,053 most popular tasks in the How to 100 million dataset. Then we leverage a pre-trained language model to encode all the steps and ASL sentences of all the How to 100 million videos. Then we can calculate the similarity between each ASL sentence and all the steps. We tried three variants of training objectives to leverage the resulted distant supervision. The first one is to formulate it as a classification problem where the video encoder is trained to predict the index of the most similar step. The second variant is to match the distribution over all the steps between the prediction from the video model and the one we obtained from similarities of the ASL sentence and steps. The third variant is to regress the embedding of the most similar step. The video encoder we mainly use in this work is Transformer. On downstream tasks, we explored augmenting video embeddings by concatenating them with the step embedding in the step knowledge base. In the experiments on step classification, recognition of procedural activities, and step forecasting, we train a shallow classifier based on the distantly supervised representations. On egocentric activity classification, we use our pre-trained video encoder as initialization. First, we would like to show a qualitative example from the coin dataset. Our model not only successfully recognizes the procedural activity in this video, but also predicts highly relevant step for each video segment without seeing any step annotation in the coin dataset. Then we compare three variants of our distant supervision and various weak supervision or manual supervision. It turns out that distribution matching in the distant supervision performs the best. Our distantly supervised representation produces strong generalization performance on 4 tasks. The main take-home message is that modern language models help reassign noisy ASRs into the clean step descriptions from wikiHow. Thank you for listening.